So this is the last video for question 1 for the FRQ portion of the Chapter 4 review. We're on part C. This question is asking between 0 and 20, so for time is between 0 and 20 minutes. The average temperature of the water is given by this function. Now remember, this is one of the 3 that we specifically talked about in the last video. We have 3 different functions that you should be able to know off the top of your head. If you see 1 over b minus a between a and b of a function, that's average value. If you see the absolute value signs outside of our integral, that's displacement. And if you see the absolute value signs inside our integral, that is total distance traveled. Okay? So here, even though it doesn't necessarily look like it when you first see it, we've got 1 over 20, the integral of 0 to 20. So they've done this math for you. If this is 1 over b minus a times the integral from a to b of a function, then this is 1 over 20 minus 0 from 0 to 20 of our function, okay? Now, it's not f of x dx, it's w of t dt, which is fine. It doesn't matter which type of function is in here, as long as the interval outside, 1 over b minus a, matches, and the 0 to 20 matches our interval, okay? Which is what we have going on here. So this is an average value function. So even if they hadn't said average temperature, we should know this is average temperature just by looking at it. So this wants us to use a left Riemann sum with the 4 subintervals indicated by the data in the table to approximate this average value. So the important thing about this that I think a lot of people forget is a Riemann sum or a trapezoidal sum, whatever type of sum it is, will approximate the integral and nothing more. This is made of 2 things. This is made of the integral from 0 to 20 of w t dt. So this is the integral. And 1 over b minus a. So 1 over the total change in time. Okay, so we're dividing by time. The integral will bring us to, will bring us the sum. The integral will add together all of the total changes in temperature, so the total number of degrees that we measure. And then when we divide that by our time interval, it'll give us the average temperature. So that's the same way we take any average. We add up all the different totals, and then we divide it by the number of totals. So this is the total number of degrees divided by the total number of time to give us the average degrees, okay? So in this case, what we need to do is use a Riemann sum to calculate this portion, and then take our final answer and divide it by 20. A lot of people have been forgetting about this part. We can't forget that the Riemann sum doesn't take this into account at all, so we need to do that ourselves. So using a left Riemann sum, I've taken my table, and I've already made my rectangles on it. My subintervals have been given to me, and when you see the word subinterval, which is right down here, right here, subintervals, the word subinterval, you can think width every time you see that. So using the 4 widths indicated by the table. So up here in my table, the first width goes from 0 to 4, okay? The second goes from 4 to 9, then from 9 to 15, and 15 to 20. I've also put my L's over the left side of each rectangle to show me that this is a left Riemann sum, so the height is going to come from the left side of each rectangle. So the heights that I will use for each rectangle are going to start here at 55, then 57 for the second, 61.8 for this one, and 67.9 for this one, okay? Those ones I can find just by looking at the table. The bases of each rectangle, however, are going to be something that I need to calculate. So when I do that, I have 4 rectangles. Each one has a base and a height. Okay, I'm going to add them all together in the end. So I just said the height comes from the left side of each rectangle. So the height here is 55.0. The height here is 57.1. This one is 61.8. And here I have 71.0. The bases of each rectangle come from the change in x values. For the bases of my rectangles, I do not just pick the left side x value or the right side x value or anything like that. I actually have to write down the width of each rectangle. So the width of my first rectangle goes from 0 to 4. So this width is 4 units wide. This is 4 minutes wide. My second rectangle, now it's important to calculate each one because they might not always match. My second rectangle goes from 4 to 9, which is a distance of 5, not 4. They're not identical, okay? My third rectangle goes from 9 to 15. This is a difference of 6. And my last rectangle goes from 15 to 20, which is a distance of 5 again. So if they give you subintervals, if they say use the ones we've indicated, that means that you just count the difference between the x values for the number of rectangles. So we have 4, so the distance between each one, we can count those and just write them down. The only time that you need to go ahead and calculate the widths of the rectangles and make them all match is if they give you a table and they just tell you the number of rectangles that they want, because that's when you get to decide the width and you want to make them all the same. In this case, they will give you the width and they say use these subintervals, so use these widths, and we can go ahead and just calculate each individual width and write them in for our base of our rectangle. Now, I have base times height, base times height, base times height, base times height. I have 4 rectangles. That's wonderful. This is a left-hand Riemann sum. That's wonderful. And I am finished. I do not have to simplify this at all because this is an FRQ. That's my answer. Sentence 1 did not say, or sentence 2 asking for this question, did not say indicate units. So this is acceptable as an answer. However, the second portion of this, does this approximation overestimate or underestimate the average temperature? This one I have to calculate and explain, okay? Now remember, I don't have any way to find the actual average temperature. I only have the numbers that I have in front of me. I don't even have to find out what these equal in order to figure out if it's an over and under estimate. What we have to do is remember that that all depends on the shape of our curve and left or right Riemann sum. So when in doubt, draw it out. That's what I always do, okay? So if we want to figure out if this is an over or under estimate, we just have to draw a sketch of a similar curve. It doesn't have to match at all. It just has to be similar. And what I mean by similar is this function is increasing. As my x's increase, my y values increase. So if I draw this like so I've got my x and y axis here. As my x values increase, my y values increase. So I start low and I go high. I have an increasing function. It doesn't matter what the shape is. All I need to know is it's going up. Okay? So it's going that way. Now that I've sketched a similar function that's also increasing, now I have to see what kind of sums I used. I used left Riemann sum, which means the left side of every rectangle touched the line. So if I break this up into 4 rectangles, just cut it in half and then cut each of those halves in half, each side of my rectangle, the left-hand side, will touch my curve. So there is rectangle 1. Here is rectangle 2, here is rectangle 3, and here is rectangle 4. This is all I care about, these 4 rectangles. Now if you look, no matter what shape curve you drew, if you drew a curvy one like this, or a curvy one like this, it doesn't matter. As soon as we draw our rectangles in there, if we drew left-handed rectangles here, 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 what you'll notice is every single one of these is underneath the curve, which means we have counted less area than is actually there, no matter what you made your curve look like. As long as your curve is increasing, going uphill, and as long as you're using left-hand Riemann sums, you will always be underestimating, because we have estimated under the actual total area. So under estimate. So we can say this is underestimating the area. If you wanted to draw a sketch to help you, that's wonderful. You do not have to mention it in your sentence. All you have to say in your sentence so that they know that you understand that this is an underestimate, all you have to say, this is underestimating the area, so that's important to say, because the function is increasing, and we used left Riemann, we used a left Riemann sum. There. So, underestimating, increasing, left Riemann sum. These two things will guarantee that it is an underestimate, and they are all you have to say in your explanation, okay? If you had a decreasing function and you used a left Riemann sum, it would always overestimate. So this is something that I find difficult to just memorize and to just know off the top of my head. So you can see here that the area of these rectangles is more than just the area underneath the curve, right? The area underneath the curve is just this triangle portion down here, which has less area than what we drew in with these left-hand Riemann sums. So because it's difficult to remember which way is an overestimate and which way is an underestimate, I always just draw a small sketch. Okay, and it doesn't even have to be that big. It can literally take you just 2 seconds, like this, on your test, and you're like, oh wait, this is under. Okay, underestimating. That's it. All right, so that's the end of question 1, and we'll go ahead and move on to question 2 in a new video.